So there we go. Now we're recording. So this first example that we have is coming up with a line and then graphing it. And so this is it's in standard form. And so what we have is it's in the form ax plus by is equal to c. And so one of the things I want to show you guys that's a quick way to do this is the slope of this is always going to be negative a over b. Okay? And the y-intercept is going to be c over b. So whatever those things are. So with the problem that we have, our a would be negative 2, our b would be 3, and our c would be that negative 9, right? So what we're going to get is our slope then is going to be, negative 2 over 3. And so that's going to give us a slope of 2/3, okay? So the slope here should be 2/3. The y-intercept is going to be negative 9 divided by 3. And so that's going to be a negative 3, okay? So we can write it as a point if we wanted. It would be 0, negative 3. Or they're probably just going to ask you for like the number negative 3. And we can check that real quick, so bear with me. I just want to see what answer they put for that. I usually like to put a point, but I wouldn't be surprised. Yeah, they just put negative 3. Do you see that? So, but that's the easy way to do it. Do you guys want me to show you the long way to do it without having to know these formulas here?
So that was kind of the issue I was having when I was doing like the actual homework.
Okay.
I was inputting the 0 and the negative 3, and it would say I had the wrong answer.
Oh, got it. Yeah, that's the only unfortunate thing about using programs like Alex or WebAssign and things like that. You'll have students who end up with having the correct understanding, but having things marked wrong because of that. So. Yeah. That's part of the reason why I want you guys spending your time doing your topics, is because I want you to see how they want the answers. But since it's asking for the y-intercept, 0, negative 3, or negative 3 would be fine. You're going to need that when you're graphing it. And so when I look over your exams, I can actually see, like, if you graphed it correctly, I can give you partial credit or even give you full credit on things that you've gotten marked wrong on the exam. Does that make sense?
Yes.
Okay, so then we got to plot this, and so the point is 0, negative 3. So that's going to be down here, right? And our slope tells us to go up 2 and then to the right 3. So what's happened here, and I'll blow this up so you guys can see, and I'm going to use a different cut. Well, I'll just use the laser. From here, I'm going to go up 1, 2, and then to the right, the 3, right? Because the slope that we have is that 2/3, right? And we can go again, go up 2 and then over 3 again, and have our points for our line. And so our solution should look something like this, right? And really we should put arrows on it, and that's what our first problem should be. Make sense? You guys got it?
Yes.
Okay, do you want me to show you how to solve this problem to put it in slope-intercept form so you could find the slope and the intercept that way?
Yeah, please.
Okay. Yeah, no problem. So here's another way to do it, just in case you're not liking that shortcut that I gave you from the standard form. What you could do is, let me just change colors. I want to solve for y. So I'm going to add 2x here. So I have to add 2x to the other side. So what that gives me is 3y is equal to 2x minus 9. Then I'm going to divide by 3 everything. And so that gives me y is equal to 2/3 x minus 3. And remember, it's y is equal to mx plus b. So we see the m is the 2/3, and our b is a negative 3. Correct? Because if I were to rewrite this so it would be with a plus, I'd get y is equal to 2/3 x plus a negative 3. Make sense?
Yes.
Okay. So either one of those, whichever one you prefer, is fine with me. It's ultimately getting to the right answer, right? Okay. So let's go on to number 2. And number 2 is simply graphing y or x is equal to 5. So when x is equal to 5, the important thing to understand here is no matter what I let y be, what's x going to equal? It's got to equal, according to this thing, it's got to equal 5, right?
5.
Yes. So when y is 0, I'm going to get 5. When y is 6, I'm still going to have x equal to 5. When y is a negative 4, x is still going to be negative 5. And so what we end up with is a vertical line. Right? If you were to have, and I'm just doing this for instructional purposes, if I have y is equal to like 3, what that's going to be is it's going to be a horizontal line crossing through at 3. Right? That's y is equal to 3, because no matter what x value we get, y is equal to 3. But for this problem, this is the answer for the graph that they're asking for. Anytime x is equal to something, it's going to be a vertical line, okay? So just think x equal, vertical line. Okay? And don't worry, I will post this video up, and I'll even post up this worked out PDF for you guys. So if you want to look at the work that I did, I'll have it posted on the announcements for you, okay? Okay, the next one. It says graph the inequality x plus 4y is greater than 16. So to do this problem, I'm going to solve it into the Slope-Intercept Form. And so what I'm going to do is I'm going to get, okay, 4y is greater than a negative x plus 16. And then y is going to be greater than 1/4 x plus 4. Are you guys okay how I got that equation? Or did I do the steps too quickly?
Yeah, yes.
You're okay with that, or do you want me to show more steps?
Yeah, I'm okay with that one.
Okay. Okay. Elizabeth, you okay with it too?
You divided the 4.
Yeah. I move the x over by subtracting, and then I divide it by 4. Yeah. Okay. So then from here, I know that my y-intercept is that 4, and then I got to go down 1 and over 4. So I'm going to have that point there. And since this thing is an inequality without an equal sign, I'm going to end up with these dotted lines, right? Does that make sense? Now from here, what I need to do is I need to clearly test this thing so that I know which side to shade. And the easiest number to pick, or the easiest point to pick, is typically the origin. And the reason I want to pick the origin is because the origin, the numbers there are 0, 0, right? So if I use 0, 0 and plug it into my original equation, don't I get 0 plus 4 times 0 is 0? So this is 0 bigger than 16? The answer is no. And since the answer is no, that means I need to shade the opposite side. So this is the solution. Does that make sense? Because when I tested 0, it was a big fat no. And if one point fails, all points on that side are going to fail. And so we have to shade the other region. Good? Okay.
I do have a quick question.
Sure.
For example, the slope was -1/4, right?
Mm-hmm.
-1/4.
Yeah.
Okay. So how do you know when to move up or down?
Perfect. So this will help answer it for you. So a -1/4, I put the negative on top, right?
Yes.
So this one's telling me go down 1. This is telling me to go to the right 4. Okay? If I write it this way, which is the same thing, because it's still a -1/4, correct? Now this is telling me to go up 1, but go to the left 4. So watch this. I just want you to be able to see this real quick. So from here I went down 1, and then I went 1, 2, 3, 4 to my point. Right? That's using the top. If I were to do the bottom one, I'd go up 1, and then I should go 1, 2, 3, 4. And my point should have been right here. So obviously my dotted line wasn't perfect, but that's how you can do it. You can go up and to the right, or I'm sorry, down and to the right, or you can go up and to the left. See how you end up staying on that line?
Yeah.
So it's either one. Basically think of the top number as telling you to go, you either go up or down, depending on the sign, and then the bottom number is telling you go to the right or to the left, depending on the sign. But it should be consistent, right? So what ends up happening is, look, if I had gone up and then to the right, I would have ended up with a point that would have been somewhere here. Well, that's not going to make that line that I want. So obviously this would be wrong. Does that make sense?
Yeah, thank you.
Okay, yeah, no problem. That's what I'm here for. I'm wanting to do these Wednesdays from 5 to 7 every week for you guys for the rest of the semester, just to be able to answer questions for you guys. Does this time work okay?
Yeah, that works for me.
Okay. So, all right, let's go on to the next one. So the next question is, let's find the equation to the line. So that's not bad. First thing we should do, it's the easiest thing we should do is try to find the slope. Okay? So if I start with this point on the left and I want to get to this point, how much did I go up to end up on that same line with that guy? How many did I go up? From here to here I went 1, 2 up, correct? So then the top number on my slope should be a 2. Now from here to get to where this point is, I've got to go 1, 2, 3, 4, 5, 6, 7, 8. So my bottom number is going to be an 8. Does that make sense? So then my slope is 1/4. Okay? And they're probably going to want your equation in the slope-intercept form. So here's how I would do it. I'm going to go y is equal to mx plus b. And I'm going to pick a point. Which point do you want me to use? This one here or this one? It doesn't matter to me. You choose. I'll call this number 1 or this number 2. Which one do you guys want me to use? Number 1 or number 2?
Number 1.
Oh, 1? Okay. That's fine. So if I use 1, hi Jackie, glad you came. If I use number 1, that point there is -3, 2. Do you guys agree with that being that number, that point? So what I'm going to do is, I'm going to say, okay, I know my slope, it's 1/4. My x number is a -3, right? My y number is a 2. Now I'm going to go try to find my b. So what I'm going to get is 2 is equal to a negative 3 over 4 plus b. And then I need to add that 3/4 to the other side. So I'm going to get 2 3/4 is my b. If you want to write it as a mixed number, sometimes professors don't like that, or I don't know what Alex will do, but we can change that to a improper, which would be 11 over 4, which is fine. So I'm going to get y is equal to 1/4 x plus 11 over 4, or that 2 3/4. And this is my answer. Does that make sense? And here, we'll check it. Number 4, let's see what they had as an answer for number 4. Oh, see, they wrote it as the 11 over 4. Okay, do you want me to show you another way to do it? I don't want to overwhelm you guys, so what do you guys think is best?
I'm okay with that method right now.
You're okay? Okay, then I'll leave it there. I don't want to overwhelm you guys. So, okay, perfect. If you would have chosen the other point and done the substitution, you should end up with exactly the same answer. Do you want me to show it if I use the other point just so you guys can see?
What was that?
Do you want me to use number 2 and show you that it ends up with the same answer? Just so you guys can see it. So again, I'm going to go, all right, so this point here is 5, 4. And so when I do it, I'm going to go y is equal to mx plus b. So my y is 4. My slope was 1/4. My x is 5. And then I've got to go solve for my b. So what I'm going to get is 4 is equal to 5/4 plus b. So then I'm going to have 4 minus 5/4 is equal to b. But 5/4 is the same as 1 1/4. So that's going to give me 2 3/4, which is my b. And if you guys don't see it, that's okay. That's the same as 16 over 4 minus 5 over 4. And that gives me my 11 over 4, which would have been the same thing. And so I get y is equal to 1/4 x plus 11 over 4. So it doesn't matter which point I would have chosen, I should get the exact same answer. Okay? All right, lovely. All right. This is the one that's a bit of a toughie for people. So they're saying, all right, consider this line y is equal to 3/7 x plus 5. And part A says, find the equation of the line that is perpendicular to the line, and then it passes through a different point. Well, if it's perpendicular, I know that the slope of the equation they're giving me is a negative 3 over 7, correct? So the perpendicular slope for this one, the perpendicular slope is going to be the opposite reciprocal. So instead of 7 over 3, we're going to get a negative, instead of a negative 3 over 7, I'm going to get a positive 7 over 3. So my perpendicular slope is going to be it's going to be a 7 over 3, right? But now I got to use these points. So for part A, and I'll write it right here so you can see it, I'm going to go y is equal to mx plus b, and my y is a negative 4. My slope for the perpendicular is going to be 3/7. My x is a negative 3, and now I just have to go find my b. So it's the same method as the previous problem that we just did. It's just understanding it being perpendicular means the opposite reciprocal, right? So then the 3's there are going to cancel. So I'm going to get negative 4 is equal to a negative 7 plus b. Adding 7 to the other side, I'm going to get 3 is my b. And so for part A, the equation should be y is equal to 7 over 3x plus 3. Is that okay? All right, I'm just trying to make sure. Okay. So for part B, they're asking for parallel slope. And since they're asking for a parallel slope, what we need to have is exactly the same slope as the original. So the parallel slope, that's the symbol for parallel, is going to be that negative 3 over 7. Okay? So y equals mx plus b. And again, they're using the same point. So I'm going to have negative 4 is equal to a negative 3 over 7 times a negative 3 plus my b. Unfortunately, this one's not going to work out as pretty as the previous one. So I'm going to have negative 4 is equal to 9 over 7 plus b. So I have to subtract a 9/7 to find out what my b is. And that ends up being a negative 5 2/7. But I'm going to show it to you. So 4 times 7 is 28. So my b in this case is going to be a negative 37 over 7. And so my equation ends up being that. We okay with that?
Yes.
Okay. All right, just making sure. I want you guys to feel really, really comfortable with this stuff for this exam. Your class has done really, really well with using Alex, which was my hope. I think it does a really good job of explaining things, and so it's been great to see people be successful with it. Okay, so here's this next one, and they give it away. They tell you it's a parabola, but the way that you could have noticed that it was a parabola is because the variable is being squared. Okay, and so I don't know if you have this down yet, but x minus h squared plus k, h comma k is the vertex. And you probably should have seen that on Alex, but I just wanted to reinforce it. So then my vertex for our problem is going to be what? What is our h? It's the 3, right? And that comes because it's in the same position as the h, and there's still a minus sign. If this had been a plus, it would have been a negative 3. Now, our k ends up being that 1, right? So then when we go to plot the point, it's going to be 3, 1. And then I don't want to go crazy with numbers, but you should know that at the vertex, that's called the axis of symmetry. And so I'm trying to save you guys some time in terms of doing the mathematics. If we have axis of symmetry, if I find one point to the right of the axis of symmetry to the same distance on the left, you'll get the exact same point. So if I plugged in 4 into this thing for x, I'd go y is equal to 4 minus 3 squared plus 1. And that would give me 1 squared plus 1, right? Which is going to give me 2. So at 4, I'm getting 2. Now, how far is that from this axis of symmetry? How far is this dot from this? How far to the... It's 1 to the right, right? If this is 1 to the right, then there should be a point, a dot, right here. Okay? And let me just show you one more. We have enough to graph it now, but I want to just show you one more. If I'd have gone y is 5 minus 3 squared plus 1, that's going to give me 2 squared plus 1, which will yield 5. So at 5, I'm going to get the point 5. That's 2 away, so 2 away should be another point. And now I have enough for my picture.
Alex requires us to have 5 points.
Oh, it does. Okay, cool.
It does. It requires a minimum of 5.
So the one thing that's cool about that is when you're doing it, though, if you just pick, once you find the vertex, finding 2 points to the right of the axis of symmetry gives away the other 2 points.
And that's awesome because I've been figuring out 5 different mathematical equations for one parabola, so you just cut my time in half.
Yeah. So, that's one of the things now. It's a bummer because if I would have known about us having this confer Zoom thing this semester, I would have done these once or twice a week with you guys the whole semester. And I would have saved you a bunch of time. So my apologies for not knowing about this confer Zoom thing that we have now. It's really kind of changed my teaching a lot with my online classes because I love to actually teach. And when you're doing online, it's a lot harder. And even when you pre-record lessons, people you don't get students questions that help fuel good instruction. You know what I mean? So hopefully this helps you for the rest of the semester. All right, let me go on to the next one. Are there any questions on this one, though, actually, before I move on? You guys okay? All right. Okay, so number 7, it says find the intercepts and the coordinates of the vertex for this parabola. If there is more than one x-intercept, separate them with a comma. So when you're putting your answers in, you're going to look for it in a comma form. Okay. So for this one, what we're going to do is to find the x-intercepts, all I need to do is set, when are you crossing the x-axis? What's your y value then?
0.
It's 0. So that's perfect. So we're going to go 0 is equal to x squared minus 2x minus 3. And here it becomes advantageous to be able to factor. Now let me know if you have an issue with factoring. I can help you with that real quick. But this is just going to be this. Does anyone need me to demonstrate how I get that? No? All right, cool. So now, to be able to find the roots to this, we're going to use what's called the product property of zeros. And the product property of zeros tells us if we have two things that multiply to equal 0, A is equal to 0, or B is equal to 0, or they both are equal to 0, right? So then what I'm going to do is I'm going to set each one of these products equal to 0. So I'm going to go x plus 1 is equal to 0, or x minus 3 is equal to 0. So in this one, x is equal to -1, and in this one, x is equal to 3. And so we end up with two possibilities for our zeros, and these are the two. So for Alex, you'd probably write it like -1, 3 would be the answer. Let me just check. And that was number 7, right? So yeah, -1, 3. And then let's see, what else did they want for that problem? And then they said separate them. Oh, find the vertex. Okay. So then the vertex, easiest way to find the vertex when you're doing this is this way. So let me erase this so I can show you. So on a number line, if this is -1, here's 0, here's 1, here's 2, and here's 3. What's smack dab in the middle? So if it's 1, right? If I go 1 to the right and 1 to the left and then 1 to the right, and 1 to the left, I end up at 1, right? So that's the x coordinate for my vertex. Because axis of symmetry, that's where our middle point is going to be. So for the vertex of this thing, I know that x is 1. How do I find my y? By plugging in. So 1 squared minus 2 is a negative 1, minus 3 will give me that negative 4. Does that make sense? If you're unclear, please.
Yeah.
Okay. If there's anyone who's unclear, please let me know. Because I know some students that struggle with this, and I want to make sure that you guys are okay with it. No? We're okay? All right, cool. All right, so the next one, it's saying graph the circle. And so when we have a circle, the formula that we have is x minus h squared plus y minus k squared is equal to the radius squared, right? So what is my h? hk is the center. So what do you guys have as your h? What do you think the h is going to be? It looks very similar to this one, right? It's got the x, it's got the square. It has a 5 where the h is, right? The only problem that we have is it's supposed to be a minus and this is a plus. So what should my h be?
Negative 5.
That's it. It's a negative 5. And then my k, we're lucky. We have the minus already, so the k is the 2. Okay? Now the radius of this thing is the square root of the 4. So see how it's r squared is equal to 4? You could just go, okay, r squared is equal to 4, and then take the square root of 4, which will give you r is equal to 2. Or without even showing that math, you can just do, all right, what's the square root of 4? Square root of 4 is 2. So now to graph this thing, I need to go to negative 5 up 2. So there is my center. And now what I have to do is have a radius of 2. So I'm just going to do the easy ones. 2 away, 2 away, 2 away, and 2 away. And then draw my circle. And that's the graph. Okay? I know my calculus students talk about when I do math, I make it look so easy. And I tell them, well, I've been doing this for a long, long time. So if I am going fast at all, please be honest with me, because I want you guys to absorb this. You know, I want you guys to understand this and do well. But you're okay? Okay. All right. All right, here's number 9. And now here it's asking for a hyperbola. So, do you guys know what a hyperbola is? Okay, so a hyperbola, typically, depending on what it is going to look something like this. Right? Or it might look like something like this, where this is the x-axis, this is the y-axis, this is the x-axis, this is the y-axis. So in this problem here, typically when we're dealing with hyperbolas or ellipses, we want the number on that it equals to be 1. Okay? So in order for this thing to be equal to 1, what do I have to do? How could I get rid of this and make it a 1? And I can't add or subtract, so I have to divide, right? So when I divide, I'm going to get a negative x squared over 4 plus 4y squared over 4 is equal to 1. Okay? And so what we're going to get is a negative x squared over 4 plus y squared over 1 is equal to 1. And here's how this thing is done. Because a hyperbola is typically, the example that we have here is going to be y squared over a squared minus x squared over b squared is equal to 1. And the distance to the center, and the center for this guy happens to be at the origin because nothing's happening with the y or the x. Because if it wasn't in the center, it would have been like this. Where HK would have been the center to this guy. I'm sure you probably saw this on Alex already. But this guy, because the positive is y, is going to open up and down. Okay? But the A and the B give us some very vital information. And here's the vital information. So my y is going to tell me to make points 1 above and 1 below. And my x is going to tell me to do points 2 to the right and 2 to the left of the center. Now I'm going to blow it up because I want you guys to be able to see this. And then what I need to do is I'm going to make a box, right? I'm sure you guys saw this on Alex, but this is how the box is made.
Yeah, when we do these on Alex, it asks us to put the dot at the center and then draw it to I forget the terminology they use. So we do basically the center, the side, and then the top. And those 3 points are what graphs our whole thing.
Oh,
so
got it.
We only get to click on those 3 spots.
Okay, so hopefully this makes it so it's easier for you to be able to at least get to those points. But now what I'm going to do is I'm going to make these asymptotes, right? And these asymptotes are these dots that go this way, right? And this way. And it's just like that. And I told you that it's going to open up and down, right? Since it's going to open up and down, it's going to look like this. And that's what the hyperbola ends up looking like. You okay with that? That one's a little bit of a toughie, right? Now, had I switched my equation and had it been the x would have been positive and the y would have been the negative, and with keeping their denominators, it would have been sideways on this graph. So what I mean by that is if I would have gone x squared over 4 minus y squared over 1 is equal to that. Instead of it opening up and down, that would have opened to the right and to the left. Does that make sense? So, yeah. So on Alex then, let me just see if I can understand what you're telling me. You do the center and you pick this point and this point? Is that what you're saying, Jackie? You pick the center and then where the vertex is for each?
You only do 3 points total. It graphs the whole thing. So you pick the center, you pick
this guy?
one of the sides, and then, yeah.
Okay. So if you would have picked this, it would have graphed it this way. Is that what you're saying?
Well, I know you pick it as so. Yeah, because you would pick your third plot would be one of the dots on the red line. Fine. So you plot the center, you plot the side of the black box, and then you plot one of the dots of the red line, and then it graphs your whole thing.
Oh, I'll have to mess with that. I haven't done that in a long time. So, but does this make sense the way I explained it? This was a little bit more confusing?
No, this makes sense.
Okay, just making sure because I don't want to confuse you guys. That's the last thing that I want to do. Okay, so now let's go on to the next one. And this is the ellipse. And the ellipse, much like this one, had this formula for opening right and left. So that's for opening to top and bottom. And so is this equation here where it's not centered at 0. The ellipse also has an equation to it, and the equation is x squared over a squared plus y squared over b squared is equal to 1. So since we want to have that again, what we end up doing is this. We get, dividing by 36, I'm going to get 4x squared over 36 plus 9y squared over 36, and that's going to be equal to 1. Right? So when I clean that up, I'm going to get x squared over 9 plus y squared over 4 is equal to 1. Since we don't have an h or a k, the center is at 0, 0. And the root of the denominator of each of those tells us how far to move along the x and y axis. So since the x is 9, the square root of 9 is 3. I'm going to put dots at 3 and negative 3. And the square root of 4 is 2, so I'm going to put dots at 2 and negative 2. And then I'm going to make my ellipse. And that's how you do that graph. Fair enough? Ellipses are awesome because it's so dang easy to graph them. Basically, just the once you find your center, the roots of the denominator yield the answer. So if I had changed this just a little bit and made it like, okay, x minus 2 squared over 9 and plus y minus 3 squared over 4 was equal to 1. The only difference here is the center of this thing would have been at 2, 3. And then my distance would have been, it would have looked like the same ellipse, just the center was moved to that new spot. Does that make sense? So all this is saying is it's just a shift over. It's not a big deal, but I just wanted you guys to see that just in case. Although I kind of doubt that the exam's going to have H and K's in them. Okay, and this is the last one, and this is the toughie. This is the, do you guys know this math that's involved in this problem? The one thing that's cool about this problem is they tell us it's a circle, right? And since it's a circle, it's going to be x minus h squared plus y minus k squared is going to be equal to the radius squared. Okay? So that means that we're going to have to complete the square on this problem. So first thing I want to do is I want to bundle x things together and y things together. So I'm going to go x squared plus 4x, and then I'm going to leave a gap, plus y squared minus 2y, and then I'm going to bring the 4 to the other side. Okay? Now, do you guys know how to complete the square? If you don't, it's okay. Okay, so here's how you complete the square. The b term, see how this is just x? This is the b term, and here where this is y, this is the b term for that. So what we do is I'm going to take the coefficient in front of the x, and that's a 4. And what I need to do every time, I'm going to go, okay, 4 divided by 2, and then I'm going to square. So what's 4 divided by 2? That's 2, and then when I square it, it's going to be a 4. So what I'm going to do is I'm going to do it in a different color. I'm going to add 4 here. Now, since I add 4 there, I have to add 4 to the other side to keep balance, right? Now, here, this is a -2. I'm going to do the same thing for it. So I'm going to go -2 divided by 2, and then I'm going to square. Well, what's -2 divided by 2? Isn't that a -1? I'm going to square it and get 1. So that tells me I'm going to add 1 here. So I've got to add 1 to the other side. Are we okay? So now we have two trinomials that we've made perfect squares. And so we need to factor them. So this first one with the x's is going to be x plus 2 squared plus y minus 1 squared is equal to 9. Are we okay with how I factored those? Yes? Okay.
Yes.
Okay. Wonderful. So what's my h? What do you guys think my h is?
2.
-2. It's -2. And the reason it's -2 is because notice that this is a minus sign and this is a plus. So that means it's got to be the opposite sign of this. So we get a -2. All right? What's my k?
1.
It's 1. And now we got to plot that. So we're going to go -2, 1. That is my center. What is my radius?
9. No, 81. No. 3.
That's it. Yeah, that's it.
3.
It's 3. It's funny. We look at it, we see r squared, and we're like, oh, let's square it. But it's actually taking the square root of that. So it's 3. So now when we plot our points, we're just going to count 1, 2, 3. There it is. 1, 2, 3. Here it is. 1, 2, 3. There's the next. And then 1, 2, 3. There it is. And this is supposed to be a nice circle. I'm not the greatest circle there are, but there it is. Does that make sense?
Yes.
Do you guys want me to give you one more just to see if you guys could do it? At least come up with the equation of the circle?
Yeah, I'm fine with that.
Okay, so I'll make one up. So let's see. Okay, let's see how that works. See if you guys can come up with the equation for my circle.
It should be x squared plus 4x, and then the y squared minus 6y equals 3.
Mm-hmm.
And then you're gonna do, you have to complete the circle, so it should be 4 over
Plus 4 for the x, right?
What's that? I'm sorry, Jackie?
Would it be the x squared plus 4x plus 4?
Plus 4, correct. That's right.
How'd you get 4?
So you take that you take this number, that 4, right? Divide by 2 and then square. So,
Oh, that's true. Okay.
so that gives me 2 squared, which is going to give me the 4. Okay, what's the next one?
Nine.
That's it. Plus 9, plus 9. So, and the way we do it is we go negative 6
9
to...
at the end of
So, let's see if you guys can get... I'll do the hard part. This is 16. Can you guys factor the other side? Actually, I can give you guys a huge hint, so you never have to think about it. Do you want the hint?
Yeah.
Never have to think about this again. It's going to be x parentheses square. What number is this? Right here.
4.
No, without the square.
2.
Plus 2. What's this number without squaring?
Negative 3.
Before you square it, those are going to be your h and k. Always. Does that make sense what I'm saying?
Yeah.
Yes.
So if you look, if we go back to the ones that we had up here, see how this was a 2? This was a 2. See how this was a negative 1? That was a minus 1. It's always going to work that way when you complete the square. Okay? All right. Here I'm going to stop recording.
And then the radius would be 4.
The radius, correct. Ooh, yes. I did that wrong. Thank you. The radius would be 16, but the radius when you did it, your HK, your vertex, or in this case the center, would be negative 2, 3, and the radius would be 4.
Okay.
But this would be the equation for the circle. Does that make sense?
Yes.
Okay.
Yes.
Let me stop recording and then I can answer any questions that you guys have just on the side. Okay?